Hey chemistry students, this is 116 homework. We're going to be predicting products of both synthesis and decomposition reactions, but the first thing we're going to do is we're going to review types of chemical reactions. So first off, we have the synthesis reaction. Remember there are 5 types of chemical reactions and we talked about those before winter break. So types of chemical reactions, our first one is synthesis, and a synthesis is where 2 or more substances go together to form one substance. So we're looking for one product. So in the example below, we have A plus B, and this goes to AB. We're going to squish A and B together. We'll check charges and put the appropriate charges on those, but we'll worry about that in just a few minutes when we actually talk about predicting products. Our second type of chemical reaction was decomposition, and this is where we have one substance breaking down into many, or at least 2. So if we have AB, it's going to be just the opposite of what it was in synthesis. It's going to break down into A plus B. Those are the 2 easy ones, and those are the ones we're going to predict products for in just a few minutes, but let's cover the other 3 types of chemical reactions. So our next type of chemical reaction is a single replacement. This is where one element replaces another in a compound. So if you can see, we have an element plus a compound. So A is going to either replace B or C, and it's going to depend on the charge of A, but we'll look at that later. So we'll say AC plus B is our product. Notice how A kicked out B, and now B is alone. If we look at our double replacement, this is where 2 compounds switch partners. So as you can see, we have AB plus CD. So A is now going to be chilling with D, and C is going to be with B. We always list the positive ones first, and we'll talk about that more when we do double replacement notes. A combustion, for our purposes, we're talking about the burning of a hydrocarbon. So combustion is the 5th type. Synthesis, decomposition, single replacement, double replacement, and combustion. So we're burning a hydrocarbon, and the products of that are always going to be CO2 and H2O. And the key here is this has to be a hydrocarbon. We can burn lots of things, but we're only talking about the products being carbon dioxide and water when it is a hydrocarbon. So let's move into the meat of the notes today, predicting products. And so we're going to just start with the 2 easiest ones. So a synthesis reaction, how do we predict the products for a synthesis reaction? The first thing that we need to do is we need to identify it's a synthesis reaction. And we are going to identify it as a synthesis reaction because we have 2 reactants and both are elements. So like we're looking at single elements. So that's how we recognize a synthesis reaction. Now, how do we predict the products? It's very simple. We are going to put the positive element first, or the cation first, and then pair it with the anion. Alright, and so we'll have to check charges and do crisscross and reduce if necessary. So let's go ahead and take a look. Our first example, we have Mg plus O2. Well, we see both of these are just single elements. We do not have a compound anywhere. So we know this is a synthesis reaction. So we know we're going to squish it together. So we look, Mg is plus 2, O is minus 2. So our compound, it's going to be Mg plus O2, arrow, and we're going to get MgO because Mg is plus 2 and O is minus 2. We do our crisscross and reduce. And some of you are like, Miss Griffith, where did that 2 on the O go? Well, that's why we have to go back and balance now. Because that 2 is not needed to balance out the single Mg, so we have to go back and balance. So to get the 2 O2s on the right side, we have to put a 2 in front of MgO, and then balance, we've now got 2 Mgs. Awesome. Let's move on to the next one. We've got Sag plus S8. So we have silver, which we know is plus 1, and we have sulfur, which is minus 2. Remember, sulfur's natural state is S8. That's why we have that there. So, writing this out, we've got Ag plus S8, arrow. We know the positive one gets listed first, so I'm going to put Ag out front. It's plus 1. S is -2, so our correct formula is Ag2S. And I'm going to lose those charges right there. And now our last step is to go back and balance. So if we look, we have 8 S's on the right. We need to get 8 S's on the left. We have 8 S's on the left. We need to get 8 on the right, so we'll put that 8 out front, which gives us 16 AGs, so we have to put a 16 there. If we want to finish this off, we can put 1 there. We can also translate from words. We know we have chlorine gas reacts with sodium metal, so Cl2 reacts with Na. Again, 2 elements. So we have 2 elements, so we know it's going to be a synthesis reaction, which we're just going to squish them together and make sure our positive one goes first. So if we look at our periodic table, Cl is -1 when it's in a compound, and Na is +1 when it's in a compound. So Na is going to be listed first, and then Cl. And Na is +1, Cl is -1, so our formula is NaCl. So we'll lose those charges. And something we maybe didn't talk about right there, this 2. So you may remember why I put that 2 right there. That's right, I put it there because chlorine, when it's by itself, is diatomic, just like that oxygen up above. So now we have to go back and balance because we don't have the correct number of Cl's on each side. So I'll put a 2 there, which gives me 2 Nas, 2 Cl's. Now to get 2 Nas on the other side, we do that. Okay, so that's synthesis. Let's see if we can't reverse that with decomposition. So first off, how do we recognize we have a decomposition reaction? Well, a decomposition reaction is very easy to identify. We have one reactant. If we only have one thing on the left side, all right, one substance on left side of arrow, we know it is a decomposition. And so how do we predict the products? It's exactly the opposite of what we did for synthesis. We're going to, instead of squishing them together, we're going to split them up. We're going to split it up into the elements, and we're not going to forget Hofbrinkel. All right, these are our elements that need a 2 beside them whenever they're by themselves. So let's take a look. That first one, we've got CO2. We recognize it's a decomposition reaction because we have one reactant. So all we do is split it up. We're going to split it up into its elements. So C plus O. Well, C is not part of Hofbrinkel, but O is, so we needed O there. So we need to go back and balance this baby. So we'll put, we have 2 O's, 2 O's. Look at that, it's 1s across the board, making it pretty simple. All right, let's move on to the next one. The next one we know is a decomposition because we have one reactant. So we have FeCl3, arrow. We're going to break it into its elements. One of them is Fe. One of them is Cl. Oh, look, Cl is a Hofbrinkel, so we need a 2 there. And now we must go back and balance. This time we'll actually need to balance because we have 3 chlorines on one side, 2 on the other side. So we'll have to balance. And they don't go into each other so nicely, so we'll put a 2 out front, which gives us 6 Cl's. How do we get 6 Cl's on the product side? Well, we put a 3 right there. And now go back and do our Fe's, which gives us 2 right in the middle there. Awesome. Now this last one is in word form, so we have to make sure we get the correct formula before we go on. But it says copper 3 oxide, and then it gave us an arrow. Very simple. So copper 3 oxide, Cu is +3, O is -2, so to get the correct formula, it's Cu2O3. And we're going to lose those so we don't get confused by them. Now we put our arrow. And again, we're just going to split it into our elements. So we've got Cu plus O, but O is a Hofbrinkel, so we need a 2. Put these little guys out front. And let's go back and balance. Maybe if I hit the right button. Okay, we could start with our CUs, but we see our O's are going to have a problem, so I'm going to put a 2 out in front of here to give us 6 O's. So to get 6 O's on this side, I need a 3 right there, and now I have 4 CUs. So I need 4 CUs on the right side, and we're done. Alright, thanks. See you next time.